Joining me now, Dr. Neil deGrasse Tyson, astrophysicist and acting director of the Hayden Planetarium.
Well, what you can do is, when the comet was first discovered, by the way, which was only 8 weeks ago,
by somebody named Yakutake.
By somebody named Yuji Yakutake in Japan.
Who discovered one before, too, didn't he?
Yeah. Comet people tend to have their names on more than one comet, and then you have to start numbering them after each time that happens.
Yakutake 1, Yakutake.
That's right. That discovered only that recently. What you have to do is, the moment you have the discovery photo, you start taking images of it during subsequent days, up to weeks, and as long as you can do this, and you take the positions on the sky, and from those positions and how fast it's changed from one position to another, you can actually calculate an orbit for the comet. And once you know the orbit, you can make an estimate as to how long it takes to make a complete trip around the sun. And when you do this for this comet, if you do the calculations right, you get anywhere between 15,000 and 20,000 years. So it's been around before, but no one on Earth today has seen it before. Well, comets, apart from being photo opportunities, because what I especially like about them, with regard to how pretty they are, is that comets tend to have their own personality, their own features, that it's like their own fingerprint. So that if any seasoned astronomer, if you showed them a picture of any comet this century, just a picture of it, they'll be able to tell you exactly which comet it was, simply by the features in the tail.
Okay, now show me the characteristics here of this thing as we hold this up.
Well, what you have is, what you can't see here resolved is the actual nucleus of the comet, which varies from comet to comet, but is typically no more than about 5 or 10 miles across. And this is that icy chunk that Professor Patterson was referring to. Out of that comes this outgassing that gives you the coma, which is the big round head, and that accounts for most of his visibility. And then through radiation pressure from the sun, the whole tail gets pushed back, and you see a tail emanating up and to the left of that image.
Did you know that in 1801, the Planet Ceres was discovered? Did you know this? Planet Ceres. You ever hear of Planet Ceres?
If you're an astrologer, you have.
Astrologers know about this?
Oh, yeah, they've got Ceres in charts. I was going to ask you about that. Why aren't the astrologers engaged?
Oh, they are. Astrologers were as pissed off as the third graders that Pluto got demoted. So 1801, Planet Ceres was discovered. Everybody was excited. And then a couple of years, within a few years, 3 more planets were discovered in orbit around the sun between Mars and Jupiter, because there was a big gap there that was not understood for a long while. And so if you have books in the early 1800s, and they discovered a bunch of these, the planet count was up to 13 for a while. Did you know that? 200 years ago, 13 planets. And then people said, no, wait a minute. These objects are kind of small. In fact, they're really, really small. And they're like, there's tons of them. And they're all kind of in the same orbital zone. They have properties that are not like these other objects we've been calling planets. And so it took 50 years, but in the early 1850s, it was widely decided that maybe we were not discovering planets, we were discovering new objects, a new kind of object, in a new swath of real estate in the solar system, which then became known as the asteroid belt.
The late Carl Sagan used to say to me, it would be arrogant for us to believe that we are the only intelligent life in the entire universe.
It'd be pig-headed, yeah. There's no, again, the sheer numbers that are involved, not only how many stars in the galaxy, how many galaxies there are in the universe, and as it is now becoming apparent that planets may be common around stars, for us to think we're the only life, there's no way to justify that, given the sheer numerics of it. In addition, the chemistry of life, the carbon molecules, the carbon chemistry that drives life as we know it, would be common everywhere in the universe, because carbon is everywhere we look. So if we were made of bismuth or some unusual element, then we might have the right to assume that we're unusual. But we're made of the most common stuff in the universe. You know what we need to know? It's not just the contest of how many planets we can find. It's deeper than that. Up until recently, we were the only example of a solar system. And so theories about the formation of planets had to, in their end, produce a solar system that looked like ours, because it was the only data point we had. By looking through the galaxy and finding other solar systems, you can then characterize the whole process of the formation of planets, the evolution of planets, and the long-term stability of planetary orbits. There's a whole new way to think about life now. Earlier, you'd thought of life as being only in planets that were not too close, not too far from the host star to get the liquid water that Michael Lemnick described a moment ago. But we now know on Europa, there are other ways you can pump energy into a system to melt the ice and give you a place where you can have life. And the better we understand other solar systems, the broader our search net can be to find the life that might be out there.
Your best guess that there is life of an intelligent form similar to us somewhere else in some other place?
Yeah, I think it's well,
likely, probably.
I'm riding the fence on that, because if you look at the history of life on Earth, by most definitions of intelligence, nearly all life that has ever existed on Earth has not been intelligent, yet it's been getting along just fine. So it doesn't appear that intelligence is a prerequisite to survive, and to exist. And so I'm happy just looking for life at all, whether or not it can do complex mathematics.
All of a sudden, art did not have to capture reality. It was no longer the obligation of the artist because we had photographs to do that. And in that period, Impressionism was born, where the artist said, I'm not going to paint what I see, I'm going to paint what this image feels like to me. 1888, we're still in this period. Van Gogh, in the early morning hours. Van Gogh paints. He paints this. It's called The Starry Night. It is the first painting I know of where the background is the subject of the painting, and that background is the night sky. And it is elevated the cosmos to become fair game to the artist. And I submit to you that scientific discovery, especially cosmic discovery, does not become mainstream until the artists embrace the fruits of those discoveries.
So the way it works now is, to be a planet, you need to check in 2 boxes. The first box is, are you round? Okay? Actually, it's 3 checks. First, are you round? Well, Pluto's round. So there it goes, all right? Second check. Are you the primary object that's in orbit around the sun? So you can't be a moon, even if you're round, and be called a planet. Got that? Gotcha, okay. So the moon is not the primary object in our system going around the sun, so the moon, though round, would not be a planet in this. So Pluto, get a check there. Pluto has a moon, a relatively big moon, but it still is the biggest in the system. So Pluto gets 2 checks.
And the third?
The third check. The third check is, have you cleared your orbit of have you cleared your orbit of orbital debris? And Pluto has not. It is in a crowded zone with countless other icy bodies in the outer solar system, the Kuiper Belt of comets.
The fastest hunk of hardware we have ever launched is the mission to Pluto right now, the New Horizons mission. It's going at like 4 times escape velocity from Earth, and it's going to leave the solar system after it swings by Pluto. It'll get to Pluto faster than any spacecraft ever would have gone that distance. It's a tiny spacecraft on the largest engines in our arsenal. You combine those 2 facts, laws of physics say this thing is going to be hauling, okay? It's going to get to Pluto by 2015. If you hitched a ride on that, it's the fastest thing we've ever launched. If you just grabbed on and didn't worry about food or want to come back or anything like that, at that speed, You would reach the nearest stars in about 35,000 years. So, we are hopelessly bound to the solar system in this regard. The distances between stars is vast. We would need to understand something new about the fabric of the space-time continuum and exploit that in order to expect to travel to the stars.
I'd like to think it's the engineers who put the thing together to make it work in the first place. You know, you see what those challenges were, and I think, well, the science is the easy part. You just slap on the
Getting
spectrometer.
up there is the tough
You
part.
slap on the spectrometer, you've got a fancy, you know, got an easy science experiment. It's the engineers who had to make this work and get it up there and get it through the atmosphere. And what was unique among the history of American missions to the planets is that it did not first go into orbit before it landed. It was a straight shot, and it went straight in, so its impact velocity was much higher than it would have otherwise been if it plopped in out of orbit. And so with the airbags and the, you know, this whole sequence, it was like a Rube Goldberg device finally landing face up. I think every generation since the space program was born has enjoyed sort of that defining image that sort of captured the sort of the soul of the nation. I remember first it was, you know, Spaceship Earth, right? The first image of full Earth, and there were no national boundaries there. There was just continents and oceans and clouds. And then there was the image of Earthrise over the moon. You know, so our mind and our body took yet another step out into the cosmos. And so a picture such as what Richard described would capture another kind of emotion, and an emotion appropriate for that next generation, because they've seen the moon and they've seen the Earth, and now there's another step out there to be taken. I think there's another hidden factor, and that is the more we find out that Mars is like Earth, and then you realize the obvious fact that there's no water on the surface, it's lost most of its atmosphere, and there's no oxygen on it, you can ask, well,
is that going to happen to us?
Is that going to happen to us? You know, we don't want to perform that experiment on Earth, all right?
So it might tell us some roadmap to avoid.
That's right, and Venus has another player in this, which has a runaway greenhouse effect. There are planet-wide factors there that it'd be nice to know, to understand them in a real experiment without having to use the Earth as that guinea pig.
Finally, what happens to the spacecraft that remain up there?
It's just hanging out. It's just
If you want to build a ship, don't drum up people to collect wood, and don't assign them tasks and work, but rather teach them to long for the endless immensity of the sea. We've got symptoms in society today. We're going broke, we're mired in debt, we don't have as many scientists as we want or need, and jobs are going overseas. I assert that these are not isolated problems, that they're the collective consequence of the absence of ambition that consumes you when you stop having dreams. In the NASA portfolio, it's multidimensional. It taps the frontiers of biology, where we look for life on Mars, chemistry, physics, astrophysics, geology, atmospherics, electrical engineering, mechanical engineering. These are the classic subjects that are the foundation of the STEM fields. Science, of course, science, technology, engineering, and math, and they're all represented in the NASA portfolio. Epic space adventures plant seeds of economic growth because doing what's never been done before is intellectually seductive, whether or not we deem it practical. And when you conduct those exercises, innovation follows just as day follows night. And when you innovate, you lead the world, you keep your jobs, and concerns over tariffs and trade regulations evaporate. To remind you, there was a court case where the school board wanted to introduce what's called intelligent design into the science classroom. And intelligent design is the premise that there's some things in nature that are not accountable by scientific means, and they must have a divine, or they would say, a source of intelligence greater than humans that made it happen. Which is not science, it's religion, basically, okay? So therefore it doesn't belong in the science, put it wherever else, it doesn't go in the science classroom. So, and that's a whole other conversation if you'd like to have it, but we started here with Pluto, so I just wanted to, and I'm almost done, believe it or not, with your answer. So, I wasn't worried at all, I just sat back. I just chilled out. Funding for science under Republican administrations has been historically higher than under Democrats. Knowing this, and knowing that innovations in science and technology are the engines of economic growth, as they have been since the Industrial Revolution, I knew, above all else, there is a truth that no Republican wants to die poor. Therefore, if you start bringing things that are not science into a science classroom, you undermine the science curriculum, preventing America from being leaders in science evermore. And then you end up dying poor.
And realize that the iron from that meteorite and the iron from your blood has common origin in the core of a star. Tell me what part of my brain is lighting up, because that excites me. That makes me want to grab people in the street and say, have you heard this? That it's not simply, as Carl Sagan said, we are star stuff, but there's a more poetic and I think more accurate way to say it. It's quite literally true that we are stardust. In the highest exalted way one can use that phrase. And so I feel, and I use words. I bask in the majesty of the cosmos. I use words, compose sentences that sound like the sentences I hear out of people who had revelations of Jesus, who go on their pilgrimages to Mecca. There's some commonality of feeling. I know it. Well, I don't know it. I want someone to do that experiment, because the day you do, if the same centers in my brain are excited by these cosmic thoughts as what are going on in the mind of a religious person, that's something to know. That's going to be really interesting finding. Because what that tells me as an educator is, let me offer the universe to people. And they'll start taking it in. And they'll start achieving those feelings that they had before. And I don't so much care whether they abandon previous feelings. I've got an offering that keeps growing, that keeps becoming more majestic. When the Hubble telescope was announced that we were going to cancel, when it was announced that we were going to cancel the Hubble telescope, the greatest outcry to not do that was not the astrophysicists. It wasn't from within NASA. It was the public. It was all over the op-ed pages and the talk shows. The public took ownership of the Hubble Space Telescope because the universe was coming into their bedroom, into their living room, onto their computer. They were a participant on the frontier of discovery. And as far as I can tell, if you let them know that it's not simply that we're in the universe, but in fact, given the chemistry of it all and the nuclear physics of it all, not only are we in the universe is in us. And I don't know any deeper spiritual feeling than what that brings upon me. And I just wanted to leave you with those thoughts. Thank you.